For section 2.2, we're going to be talking more about linear functions, and we're going to focus on graphs of linear functions. When we're thinking about graphs of linear functions, there are three basic ways that we can graph it. The first way is by plotting points, and if we're going to plot points, we would use a t-chart, and we would have to plot at least 2 points to make our line. As long as you've got at least 2 points, you could draw the line through it. When I'm doing it, I will do at least 3 just to make sure that we didn't accidentally make a mistake. But as long as you've got at least 2, you can draw your line through those points, and as long as those points are correct, your line should be fine. The second way is by using the initial value, and that is the output when the x value is 0, and so we can find that just by plugging in a 0. And then we can also use the rate of change, which is called the slope. When we do that method, we're using what is called slope-intercept, the slope and the y-intercept, and that's going to be a very helpful way for us to graph lines as well. The last way, which we're not going to use in this class, but we can do transformations of the identity function, f of x equals x. Honestly, that's not a very efficient way, so we're not going to use that method as we go through these graphs. Let's get right to example 1 here. We're going to graph this first one by plotting points. So the directions here say we're going to plot points. So that means we're going to make a t-chart, and when we make our t-chart, we have our x column, and then instead of f of x, I'm just going to use y because that's what our graph is labeled anyway. It doesn't really matter. F of x and y are basically interchangeable. And we want to pick values that are convenient for us, so 0 is almost always a convenient value. And then, since we're going to be multiplying by a fraction of 2/3, I would say we want this to come out nicely, so multiplying by multiples of 3, since 3 is the denominator, is going to be a good option for us. So let's try 3 and -3. And we will plug those numbers into this function, so f of 0 is going to be 5 minus 2/3 times 0, and 2/3 times 0 is just 0, so that goes away, and this will be 5. The next one, 5 minus 2/3 times 3. And you can use a calculator for this, that's fine, but I know that 2/3 times 3 is 2, so it ends up being 5 minus 2, and that's going to be 3. And then for this last one, 5 minus 2/3 times -3, and again, you can use a calculator on that, but that's going to end up being 5 plus 2 because you've got a negative and another negative multiplied together. It turns it into a positive. So 5 plus 2 is going to be 7. Then we're just going to graph these points. So 0, 5, x is 0, y is 5, goes right there. 3, 3, x is 3, y is 3, goes right there. And -3, 7. So x is -3, y is 7, goes right up there. And then I will try to do my best to draw a line through here. It's going to look something like that. And when you're doing your homework, I don't think you have to actually put any points on. You're going to want to make your t-chart, and then what you'll do is you'll choose the line tool, which is going to look something like this. It'll be in a little box at the bottom, and it'll have a picture like that. And you'll just click once here and click a second time here, and it will automatically make your line go through. So when you're doing your homework on the computer, that's how that's going to look. Now, the slope of a line, which is the rate of change of the line, is thought of as its rise over its run. In other words, its vertical change over or divided by its horizontal change. And algebraically, as we think about this, we find the slope using this formula, m equals y2 minus y1, and then that's divided by x2 minus x1, and all that they're doing when they use that formula is they're thinking of this as the first point would be considered x1 comma y1, and then the second point would be considered x2 comma y2. And it's very important to remember that when you have your ordered pairs, the first number in each ordered pair is going to be the x's, and they go on the bottom of your fraction. And the second number in each set of parentheses is the y's, and they're going to go on the top of your fraction. That is a very common mistake people make, is they don't pay attention to their x's and y's. So for slope-intercept form, graphically in the equation f of x or y equals mx plus b, the b is the vertical intercept, which for us on graphs is typically the y-intercept of the graph, and it tells us that we can start our graph at the point 0, comma, whatever b is. So you saw in that last example we started at 0, 5, and that would be our y-intercept. The m is the slope of the line, and that tells us how far to rise and run, vertical change and horizontal change, to get to the next point. Once we have at least 2 points, and again, I tend to put as many points on as possible when I'm doing this so that my line looks nicer. On the computer, when you're doing the homework, you just need 2 points because it automatically makes a straight line. But once we have at least 2 points, we can extend the graph of the line to the left and the right and get the full graph. Now we're going to graph, for example 2, f of x equals negative 2/3 x plus b, or plus 5. So you'll notice this is in our format of y, or f of x, equals m times x plus b. And we can see here this is going to be the m, the number in front of the x is always the m, and then the b is always the number that's over here by itself. So in this particular case, we're going to start at the intercept of 5, which means 0, 5 is the point that we're going to start on our graph. So 0, 5 is going to be right there. On the y-intercept, it's always in the middle. On this y-intercept, you've got to start in the middle. And then from the slope tells us negative 2/3. Well, that negative, we're going to put that with the top. So that means the vertical change is that we're going to go down 2 and over to the right 3 to get to our next point. So that's our next point on the graph, and we can continue doing that down 2 and over 3. And then once we have that pattern established, we can, again, on the computer, once you get 2 points, you can draw the line, but we could also go up 2 and to the right 3, and we can see that that point would also be on the graph, and that is going to be our line. So you may notice this is actually the exact same equation as the first example we did, and the exact same line. We just graphed it in a different way. And once you learn slope-intercept form, that makes this much quicker for us to be able to graph. We don't have to make a t-chart every time. For example 4, we're going to match the equation with one of the lines in the graph. And so we're going to start with kind of comparing these. I guess the one that when I look at these, I'm going to start out looking at these things right here. So I've got these intercepts, and specifically, this is the one that's different. So that makes it really easy to differentiate from the other ones. So right away, we know that g of x is going to be the one that goes through with a y-intercept of negative 3. So this one down here, I'm going to go ahead and label that one g of x, the green one. I suppose I could use the correct colors. Why don't I do that? I'm going to use the correct colors here. So green, g of x. Okay, then you'll notice all the other three, their intercept is right up here. They're all together, so that doesn't help us at all with those. We've got to look at the slopes. So the next thing I'm going to do is I'm going to check out the slopes here. So the slope on the first one is 2. We've already used b, so that one's gone. The slope on the third one is negative 2, and then the fourth one is 1/2. So the one that's different here, the most different, is this one because it's negative. Well, that means instead of going up and to the right, this one's going to go down and to the right. So let's take a look from here which one goes down and to the right, and specifically goes down 2. And as a fraction, we think of that as 2 over 1, so it's going to go from this point down 2 and over 1, and we can see that is the purple one. So I'm going to switch to purple here, and I'm going to label that one h of x. So that's the purple one. Then the other two, One of them has a slope of 2, which would be 2 over 1. The other one has a slope of 1/2, so we just want to count the slopes. So the one that has a slope of, let's do the 1/2 first. Up 1 and over 2, that's going to be this red one. So that's this one down here. We know that's going to be j of x. And then that leaves it, we can double check, but it means the blue one should be a slope of 2 over 1 from right here. So up 2 and over 1, we see that, and that's going to be f of x. Now, again, on your homework, it's going to be a drop down, and you'll just select, I think you select the colors to match with your letters, but that's, just be careful with those. You'll just pick the right colors, and they match up that way. The horizontal intercept, we already talked about the vertical intercept, but now we're talking about the horizontal intercept, which is the one going left and right, is what we would typically call the x-intercept of the function, and that's where the graph crosses the horizontal axis, or what is typically the x-axis. If a function has a horizontal intercept, you can always find it by solving the equation f of x equals 0. So that means in example 5 here, when it says find the horizontal intercept of f of x equals -3 plus 1/2 x, what we're going to do is we're going to take this f of x and replace it with a 0. So it's going to look like this. 0 equals -3 plus 1/2 x. And now the goal is, just like when we were solving some equations in the last chapter, we're going to try and get this x by itself. So we're going to try and get that x by itself, and the first thing that we have to do is we kind of start on the outside layers, so we're going to add 3 to cancel out this 3. And if we add 3 to the right side of our equation, we have to also add 3 to the left side of our equation, and that's going to give us 3 over here equals, that canceled out, and we'll just have 1/2 x left over. Next, to finish getting that x by itself, when a variable is multiplied by a fraction, we want to multiply by the reciprocal. So the reciprocal, if you remember, is where we take a fraction and the numerator becomes the denominator, and the denominator becomes the numerator. So that's going to be, we're going to multiply this by 2 over 1, which is just 2. And when we multiply on the right-hand side, this fraction just cancels out. And then when we multiply on the left-hand side, 2 times 3 we know is 6. So that fraction is gone, all we have left is the x. And that gives us the horizontal intercept. So our horizontal intercept is going to be the point where x is 6, and then remember the f of x, we replace that with a 0, so it's going to be that ordered pair, 6, 0, and that's how they'll want you to enter those points in your assignment, is as an ordered pair, with the x value coming first, comma, 0 for the y value. We have a couple special types of lines called vertical lines and also horizontal lines. A vertical line is a line through a point a comma b, and it will have the equation x equals a. And we'll look at this in a minute. The other type is a horizontal line, and if it goes through the point a comma b, it's going to have the equation f of x, or y, equals b. So if we think about this, if you think about a point a comma b, if we've got a graph here, and we've got this point a comma b, wherever it is, let's just make it 2, 3. If this is a vertical line, let's make this one orange. If it's a vertical line going through that point, whoops, I didn't draw that very well, but it goes through the point 2, 3. If you think about all the other points, if my line was a good line here, this point right here would be 2, 0. This point, down here could be something like 2, -3. This point right here would be 2, 1. And hopefully you see what's true about every one of those points. X equals 2, and that's where this equation comes from. All the x values on that line are always 2. It doesn't matter what the y values are when you're dealing with a vertical line. So you have to be careful when you have a vertical line. That's going to be the x value is not changing, so it's x equals whatever that number is. Generically, it's a. If we drew a horizontal line through that point, so let me use green for that, did a little bit better that time. If we think about all those points, notice we've got 2, 3, this one would be 1, 3. If we went here, that's 0, 3. If we went back here, this is going to be like -3, 3. And if you look at that, notice this time all the y values are the same, or the output values are all the same. And so that's how we get the equation f of x would equal 3 in this case, with that point being our point that they go through, or you could also say y equals 3. So that's where this comes from. To clean this up a little bit and just remind us, let me do this. That's what I want to do. All right. So just to remind us, when we're dealing with a vertical line, the x values will never change. That's why you get x equals a. When we're dealing with a horizontal line, the y values will never change, and that's how we get the equation f of x, or y equals b. For this one, we're going to do exactly what I was just kind of trying to show you. Let's go ahead and use orange. And what we're going to do is write an equation for the line. And notice this line, if I just take a look at a few points, here we have this point, this is 3, 2. This point is 1, 2. This point right here is 0, 2. And that's probably enough to emphasize our point, but let's go one more, -4, 2. And we see that the x values are all changing, but in this case, y equals 2. Or like I said, you might see it written as f of x equals 2. Or if you're good at memorizing, if you remember that it's a horizontal line, it's always just going to be y equals, and then the easiest point to look at is probably this one, the intercept. But it'll be y equals 2, and that's it. In example 7, we're going to write the equation, but this time it's for a vertical line. So again, probably the easiest thing is to check this out. We know that point is 2, 0. If we check this point, let's say up here, 5, or sorry, that's not true. It'll be 2, 5, x value of 2, y value of 5, this one. 2, 3. So we can see what's not changing. Well, in these problems, the x value is, or in those points, the x value is always 2. So that is the equation of our vertical line. Not only do we have vertical and horizontal lines, we also have lines that are called, special lines that are called parallel and perpendicular lines. So two lines are parallel if and only if m sub 1 equals m sub 2. Now hopefully you remember from a couple slides ago, the m sub 1, the m is the slope of a line, so they're just comparing the slope of the first line with the slope of the second line. So this m sub 1 equals m sub 2 just means that the slopes are equal. That's important. Or the other way you could think of this is if both lines are vertical, then they don't have slopes. Because they're vertical lines, and so that would be the other option. If two lines are vertical, they're parallel, or if the slopes are equal, they're parallel. So let's take a look at example 8, and this will be a little bit of a new type of problem here. Find the line parallel to y equals 3x plus 6. What we're going to do is we're going to focus on slope-intercept form, which looks like this. And we're going to use the information that we know. Now, if we want a line to be parallel to this line, the slope of that line is, again, it's always the number in front of the x, so that slope is going to be 3. We're going to use that over here, y equals 3 times x plus b. Okay, so the slope in parallel lines is going to be equal. So if the slope of the first one is 3, the slope of the second one has to be 3. Then they're going to give us an additional point. That additional point is 3, 0. So remember that means the x is 3 and the y is 0. So we're going to plug those numbers in. So we're going to have y is 0. Then we've got the 3 from the previous slope, but we're going to put in an x value of 3 from right here. So that's going to go in there, and then plus b, and then our goal is we need to try and figure out what b is. So looking at this one won't be too bad. We're going to have 0 equals, hang on, let's do some simplifying first here. So we're going to have 0 equals 9 plus b, and then we're going to subtract 9 to get that b by itself and cancel this out. And so we're going to end up with b equals negative 9. It looks like I ran off the bottom of my screen there. Okay, so b equals negative 9. That negative 9 has to go back up into this spot right here. So looking at that equation, our equation will say y equals 3x, which we already knew, and then instead of the b, we're going to put in this negative 9 here. So negative 9 goes in there. And that is the equation. Again, you might see it written as f of x equals 3x minus 9. And that is totally fine as well. It doesn't matter. Either one of those is going to be correct. And usually, on your homework again with the computer, usually they have the y equals or the f of x equals outside the box, and you just fill in this inside part in the box. But you'll just have to look. If it's not outside, then you'll type it in. Next, we want to talk about perpendicular lines. So perpendicular lines are a little bit different. Perpendicular lines, if you remember, are lines that form a right angle where they intersect. So perpendicular lines, here's how we can tell if two lines are perpendicular. The way our book describes it is m sub 1 times m sub 2 equals negative 1, or I find this one more helpful. If you know the slope of one of them, to find the slope of the line that's perpendicular, you're going to take the opposite sign, and then you're going to take the reciprocal. This is just a fancy way of writing the reciprocal of your slope. So let's take a look at this example 9. It says, find the slope of a line perpendicular to the line with a slope of 2. So we want to think of 2 as 2 over 1. We want to think of it as a fraction. So what we're going to do is we're going to take the opposite. So since 2 is positive, our new slope will be negative. And then we want the reciprocal also. So instead of 2, we're going to flip those, and it'll be 1 over 2. So for that one, that is going to be our new slope of the line that's perpendicular to that one. For part B, again, we want to think of that negative 4 as negative 4 over 1. So since it's a negative already, we're going to change the sign, and ours is going to be a positive. And then we're going to take the reciprocal, so the 1 will go up on the top, and the 4 will go on the bottom. And that is going to be the slope of a line that is perpendicular to the line with a slope of negative 4. Then the last one is already in fraction form, 2/3. So we can see it's a positive, so our new slope has to be negative since we want perpendicular. Change the sign and change the fraction. We're going to take the reciprocal. So instead of 2 over 3, we're going to have 3 over 2. So if all we're trying to find is the slope of a line that's perpendicular, we take the opposite reciprocal, which is what this little equation is telling us to do right there, even though it can be confusing. But you just change the sign and you change the fraction to the reciprocal. For example 10, find the equation of a line perpendicular to f of x equals 3x plus 6. So this is the same line we were dealing with before. The difference is, and it's going to go through the same point, 3, 0, the difference is when we find the original slope this time, we can see that that original slope is a 3. So the original slope is 3. Our new slope, remember we can think of that as 3 over 1. So our new slope, let me change colors here. Let's change to green. Our new slope for this second line, we'll say, is going to be change the sign. So it was positive. Our new slope will be negative. And take the reciprocal of the fraction. So that's going to be 1 over 3. So that's going to be the new slope we're going to use. And remember, we also want to use our y equals mx plus b form. So using that, we're going to have y equals, the new slope we're going to use is negative 1/3 times x, but we don't know what b is yet. that's where, again, we're going to take these points, and remember this is x and y, and we're going to plug them in. So in place of the y, we're putting in a 0, equals, we're going to have negative 1/3, which we already had from before, and in place of the x, we're going to put in a 3. And then our goal is to simplify and solve. So 0 equals negative 1/3 times 3. You can use a calculator. You're going to get negative 1 plus b. And then to solve that, we need to add 1 to both sides to get that b by itself. And that will give us b equals negative 1. So remember what that means. We're going to plug that back up into here. So that equation is going to say y equals, our slope is negative 1/3 x, which we already knew, and then we just figured out that the b value is, whoops, hang on. Let me erase that because I'm going to mess everybody up because I made a mistake. Right here, we added 1 to both sides, so it's not b equals negative 1, it's b equals positive 1. So now let's come back. We already knew that the slope was negative 1/3, and we have x, and then this time we know that the b value is plus 1. So that will be the equation of our line that you'll put into the box on the homework, or again, you might put an f of x there in the front instead of a y. Either way is going to be fine. For example 11, they're going to give us a little bit more work to do. It says a line passes through the points negative 2, 6, and 4, 5. Find the equation of a perpendicular line that passes through the point 4, 5. So here's what we have to do this time. We have to actually go all the way back, and we have to figure out the slope of this line, and we have to figure out that slope using our slope formula. So that said y2 minus y1 over x2 minus x1. And I don't think we've used that formula yet, so this will be the first time for that. But what I'm going to go ahead and do is I'm going to underline my x's in blue and my y's in purple. And I know that the y's should go on the top. Now we do have to make our order the same, so whichever one you put first. I'm going to put the 6 on the top first, minus the 5. And that means when I do my denominator with the x's, I have to use the negative 2 first. Since these two are grouped together, I have to do the negative 2 first, since I did the 6 first on the top, minus, and then we've got 4 there. Then we want to just add those together, or subtract them, I guess. So 6 minus 5 is 1, and negative 2 minus 4 is negative 6. So our original slope is negative 1/6. We need to come up with a new slope. So our new slope, we'll just call it m sub 2. Remember, we changed the sign. So this one was negative, our new one will be positive, and then we take the reciprocal, and the reciprocal of 1 over 6 is going to be 6 over 1, which is just 6. So then we go back to our slope-intercept form, and again, to remind us of that, y equals mx plus b. So that means we're going to have y equals positive 6x plus b. And the point that they told us to use was this one right here. And remember, x is the 4 and y is the 5. So the 5 goes in over here. We've got, whoops, undo that. We've got 6 for our slope. X is 4. And then we've got to figure out what b is. So I'm going to move that up here. We've got 5 equals 6 times 4 is 24 plus b, and then the math we have to do there to get the b by itself, subtract 24 from both sides of our equation. That one cancels, and we're going to end up with negative 19 as our b value. So again, what that means we're going to do, we're going to go back to this equation right here, and our answer is going to be y equals 6x, which we already knew, and then we just figured out the b value is negative 19, so minus 19. And that is the equation of that line. So that one's a little bit longer process because we have to find the slope first, then take the opposite reciprocal of it, and then plug it back into our slope-intercept form to figure out the y-intercept. Another thing to make note of is when you're dealing with perpendicular lines, a vertical line and a horizontal line are always perpendicular. You can't compare their slopes because vertical lines don't have slopes. So in that special case, when you're dealing with vertical lines and horizontal lines, they will always be perpendicular. We also want to talk about intersections of lines. And intersections are just where, just like on a road, an intersection is where two roads meet. Well, the intersection of lines, or anything, is where they meet. So we're going to go ahead and graph these two lines, h of t equals 3t minus 4, and j of t, which is 5 minus t. And just to clarify, this one we are not talking about x's, we're talking about t's. So I just used a generic graph here on all of these, but technically we're talking about t's now. So looking at this, let's graph this first one. We start at our y-intercept of negative 4, so we're going to start down here at the point 0, negative 4. And then our slope says up 3 and over 1. So up 3 and over 1 would put us right there. Up 3 more and over 1 would put us there. We can do that again. And like I said, I like to have as many points on my graph as possible, so I'm going to go down 3 and to the left, and we can see that's also part of that same line. So, if I draw my line through there as well as I can, that's what the h of x will look like, or h of t, I should say. Then I'm going to do the other one. I'll do that one in green. So we're going to do this one. Now we have to be a little bit careful here. This is not in the right order, so we may want to rearrange this. Our t part should always go first, so that negative goes with the t, and it's going to be negative t, and then the 5 is positive, so it'll be plus 5. So we want to rearrange that so that we can find our slope and our intercept easily. So now we're going to start at 5 on the x or the y-axis, and that's going to be straight up at the top there, 5 spaces up. Now, there's no number in front of the t, there's just a negative sign, but automatically when there's no number, we know that it's a 1. So that's actually going to say we're going to go down 1 and to the right 1, down 1 and to the right 1, down 1 to the right 1, and so on. I don't like that. Did I mess something up? Negative 4, up 3 over 1. Nope. Okay, and then 5, and down 1 over 1, down 1 over 1. Okay. Well, that is correct. The reason I didn't like it is because it doesn't hit at a nice convenient spot for us. But I think this happens sometimes on your homework as well, and they ask you to estimate to the nearest half of a unit. And so if we're going to estimate to the nearest half and we're trying to find this point right here, we can see it's, as far as the x value, it's going to be a little bit bigger than 2, and as far as the y value, it's going to be between the 2 and the 3. So I'm just going to go with halves there. So I'm going to say that's probably about 2.5, 2.5 and for the x, and I think about 2.5 for the y. And so if we are given a graph and we're supposed to find the solution and it doesn't come out exactly, then we are going to want to estimate to the nearest half, or whatever the directions on that particular problem tell you to do. So here's the computer version of this graph, and you can see, yeah, it didn't come out evenly, and it did hit a little bit to the right of the 2 and below the 3. So we can see that a little bit better. It's not a half, but it's still going to be in between those, and again, we estimate those. But for this next example, what we're supposed to do is we're supposed to find the vertical intercept for the red line, j of t. So the vertical intercept is going to be on the vertical axis, which is going to be right up here, and so the coordinates of that will be the point x equals 0 and y equals 5. Remember, your vertical axis, or your vertical intercept, which is typically the y-intercept, The x value will be 0, and the y value, or the second number, will be whatever. For part B, we want to find the horizontal intercepts of that same graph. So horizontal, and it's still the red line, so that's going to be this one over here. And notice it hits there at 5 also. The difference is this time it's the x value that's a 5, and the y value is a 0. So for a horizontal intercept, that's typically x coordinates, x-intercepts I mean, and that's going to be, the first number is something, and then the second one is a 0. For part C, we want to find the slope of this line, and we're still dealing with the red line. So let's find the slope. And to do slope, you just need to find some point and then go to another exact point. And this one's really convenient because the exact points are every one of these corners here. So we can see we're going down 1 into the right one, down 1 into the right one, down 1 into the right one, down 1 to the right one. So as a fraction, the down one means -1 on the top, and then to the right one means 1 on the bottom, and -1 divided by 1, that can be simplified, that's just -1. So -1 is the slope of that red line. Now we just figured out that the slope of j of t, the red line, was -1. Part D here asks us, is j of t parallel or perpendicular to h of t, or neither? Now just looking at it, if our graph is good, it doesn't look like that forms a right angle, and it definitely intersects, so it's not parallel. But let's check this for sure by finding the slope of h of t, which is the green line. So we need to find an exact point. Here's an exact point, and here's another exact point. So we're going up 3 and to the right 1, and you may remember that from when we graphed it, but our slope there is going to be 3 over 1, which is 3. So this is the slope of the second line, this is the slope of the first line. Now remember, if those lines are parallel, these slopes should be equal. So clearly, -1 does not equal 3, so these are not parallel. The next option that we check out is, are the slopes opposite reciprocals? Well, they are opposites, because this one is negative and this one is positive, but they're not reciprocals. If you take the reciprocal of 3, it becomes 1 over 3. So if it's going to be perpendicular, this slope up here would have to be -1/3, and it's not. So these are also not perpendicular. My eye disappeared. Okay, so since they're not parallel and they're not perpendicular, we would say that our answer is these are neither. They're not perpendicular or parallel. For letter E, using the same graph, is h of t, which is the green line, an increasing function, a decreasing function, or neither? So looking at this green line, it's this one right here, and if you remember, our idea for an increasing function was that it would be going up from left to right. Our description of a decreasing function is that it would be going down from left to right. So h of t, as we can see, it is going up from left to right. So h of t is an increasing function. Neither would be if it's just a horizontal line. Now let's quickly check it since we're looking at these. J of t, if you look at j of t, you can see it's going down from left to right. So j of t would be decreasing. And with a line, it's easy to tell that because of the slopes. If the slope of a line is positive, that means it's going to be increasing. If the slope of a line is negative, that's going to be decreasing. And if you look back, your slope of h of t was 3, so positive, increasing. Your slope of j of t was -1, and negative means that it's going to be decreasing. Our last example here is example 14, and it says using these functions, h of t equals 3t minus 4, and j of t equals 5 minus t, for what values of t is h of t greater than j of t? Well, for this, we probably should actually find the the real point of intersection. We estimated, I should say, before that it was 2.5 comma 2.5, but we can see pretty clearly from this better picture that it's not really 2.5 comma 2.5. So here's how we would algebraically find that intersection point. We take this function right here, the 3t minus 4, and we want to know when does it equal the other one, 5 minus t. And then we have a little algebra problem here, and we're going to start out by, we want the t's on the same side, so we're going to cancel out this t over here on the right by adding t. Now remember, that's a 1t, so 3t plus 1t is 4t. Minus 4 equals 5. And then we want to cancel out this minus 4, so we're going to add 4. And that will give us 4t, this cancels out, equals 9. And then we're going to get rid of the 4 by division. So we find out t, and if we divide that, we're going to get 2.25. So we weren't terribly far off, but it wasn't exactly right. And then to find the other one, we just plug that 2.25 in for either one of our t's. And I think the j of t is going to be the easier one. So I'm going to plug it into the j of t. I'm going to switch to blue here. So j of t, this is the second part of the problem. Whoops, let me get rid of that. I'm just going to use y instead of j of t. So y equals 5 minus, and here we're going to use that 2.25, and just on your calculator that's 2.75. So the actual ordered pair where these things intersect is the point 2.25. I'm going to run out of space there. Hang on, let me see if I can fit it in. And 2.75. I did run out of space. Well, you know it's a 2.75. So, now here's what that tells us. Because the question wasn't actually where do they intersect. The question was, for what values is h of t greater than j of t? Well, h of t, remember, is the green line. J of t is the red line. They want to know when is the green line higher than or greater than the red line. So that's going to be this area right here. So that means starting at 2.25, let's switch to orange. Starting at 2.25, the green line is going to be greater than that. Well, it's actually after that. And then forever on, it's going to be greater than. We're going to use our interval notation. Infinities always get parentheses. And then at 2.25, they're equal, right? So it's only when it's greater than 2.25 that the green line will be greater than the red line. So that's how you'd find that. You need to know the intersection first, and then you just pick which side. Is it the left side before the intersection where it's greater, or is it the right side after the intersection? And in this case, it's the right side. That is the end of section 2.2. So go ahead and check out those 10 graded problems, and I'll be working on that assignment, and then check out our next video for section 2.3.